Hello viewers, welcome to my channel once again. In today's video, we are going to discuss Jamb physics syllabus. If you are one of those candidates who are preparing for 2023 Jamb and you are looking for Jamb syllabus that will make you prepare better, this is the right place for you. About a few days ago, we discussed Jamb use of English syllabus. However, in today's video, we're going to discuss physics Jamb syllabus. If this is your first time of coming to our channel, consider subscribing to our channel for upcoming useful videos. Now let's start. Here is the first topic that they are going to give you in Jamb use of English, which is measurement. And when talking about measurement, it is categorized into two. One of them is length, area, and volume. This is length, area, and volume. Another length, area, or volume, we have meter rule. Where meter rule is the material that can be used to measure the distance between 2 points. This is vernier calipers, which can be used to measure the diameter of a tube. And this is micrometer scale gauge, which can be used to measure the diameter of a thin wire and measuring cylinder. Then B, we talk of mass. Under this category, you are expected to learn the unit of mass, which is kilogram. Use of simple beam balance to measure mass. Then concept of beam balance. Time. Then under time, we have measuring time devices such as stopwatch, clock, and so many of them. Then we talk of fundamental physical quantities. Under fundamental physical quantities, when talking about fundamental quantities, there are those quantities that are independent of other quantities, and we have length, time, and mass. Where the unit of length is meter, unit of time is second, and the unit of length is kilogram. Then we talk of derived quantities and their units. Derived quantities are those ones that are obtained by simple combination of fundamental quantities. We have force, velocity, acceleration, and so many of them. Then here we talk of combinations of fundamental quantities and determination of their units. Combination of fundamental quantities lead to derived quantity. Then we talk of dimension. For example, the dimension of time is liter t, dimension of distance is liter n, dimension of mass is liter m. The definition of dimensions, simple example. And here is limitation and experimental measurements, that is simple measurements. Having known that, let us jump to the next stage. Here we talk of accuracy of measuring instrument. For example, a vernier caliper, micrometer scale gauge. What is their accuracy? It will come out in the exam. And some of them, other ones like meter rule, I think the accuracy of meter rule is 0.01 centimeter. Then simple estimation of errors, that is errors found in measuring instrument. Significant figure, standard form. When talking about standard form, we have standard form and ordinary form. In standard form, you have, for instance, 3 times 10 raised to the power of something, that is standard form. Then here we talk of measurement, position, distance, and displacement. When talking about measurement, we know what measurement is now. Position is the reference of, that is the position where an object is observed in air or in space. We call that one position. Then distance and displacement. When talking about distance, is the length between 2 points. Displacement is also the length between 2 points. But when it comes to distinction between distance and displacement, when talking about distance, it is a scalar quantity. And when talking about displacement, it is a vector quantity. So that is the difference between distance and displacement. The concept of position and coordinates, that one you just have to know the little arithmetic, how to do little arithmetic expression on graph. Their frame of reference, they are so very simple. Then when we move further, you see topic 2, which is scalar and vectors. When talking about scalar quantities, they are those quantities that have magnitude but no specified direction. Then when talking about vector quantities, there are those quantities that have both magnitude and direction. Here are examples in 2, which is I. They say we should give the examples of scalar and examples of vector. Examples of scalar we have length, mass, and time. Then we're talking about example of vector, we have displacement, acceleration, velocity, and so many of them. Then here is relative velocity, followed by resolution of vector into two perpendicular direction. Here you just have to possess little knowledge of trick and graphical method. So let's move further. Here we talk of motion. So motion is said to be done whenever an object is forced to move from one place to another. Then we have different types of motion. We have translational motion, which is also known as motion in a straight path, oscillatory motion, which is the to and fro movement of an object, rotational motion, which is also known as circulatory motion, spin and random motion. When an object is moving randomly or in spin form, the movement is called zigzag movement or haphazard movement. That is when it is moving in a non-directional form. Then here is B, which is relative motion, cause of motion. The cause of motion is force. Then we have two types of force. We have contact force and non-contact and force field. So when talking about contact force, is the force of push and pull. Then when talking about force field, under force field you see things like magnetic force, gravitational force, and electric force. So that is all you need to know in this category. When we move further, we have linear motion. Under linear motion, we have speed, velocity, and acceleration. However, velocity is the rate of change in displacement per time taken. Speed is the rate of change in distance per time taken. The difference between speed and velocity is that while speed is a scalar quantity, velocity is a vector quantity, and acceleration is the rate of change in velocity per time taken, and it has the formula of A equal to V over T. From here we talk about equations of uniformly accelerated motion. We have about three equations of motion. One of them is V equal to U plus AT, followed by S equal to UT plus half AT square, and the final one is V square equal to U square plus 2AS. Then we talk of motion under gravity. When an object is coming down or is going up, such that type of motion is called motion under gravity. And what happens under gravity is that when an object is going up, it is negative, and when it is coming down, it is positive. So we also make use of equations of motion to solve problems under motion under gravity. But the only contradiction is that while the object going up is negative, the one coming down is positive. For example, if the catapult is fired upward, what we are going to use is negative. When it comes down, you use positive. Then in IB here, it is a distance time graph and velocity time graph. In this place, I just have to possess little knowledge of graphic. Then here is instantaneous velocity and acceleration. Instantaneous velocity is the velocity at any instant time, and instantaneous acceleration as well is the acceleration at any instant time. So here is projectile. When talking about projectile, it is the parabolic movement or the curved movement of an object. When you fire catapult, from that your point, it will move in a curve form and go and land in a new place. So such that kind of movement is called projectile. Then here is calculation of range. When talking about range is also known as the total horizontal distance covered by a projectile body. Then maximum height is the maximum height attained by a projectile body, and time of flight is the total time take for an object to move through that curved path. Then the height is the maximum height. From here we talk of applications of projectile motion. For example, to fire these nuclear weapons from one place to another. Then here we talk of Newton's law of motion. We have about 3 Newton's law of motion. One of them is first law of motion. which says that every object will be in state of motion or uniform, every object will be in state of rest or uniform acceleration motion unless it is being acted upon by external forces. Then we talk, this Newton's first law of motion is also known as law of inertia. Then we talk of mass and we talk of force, where force is the product of mass and acceleration. Then here is a relationship between mass and acceleration. The relationship between mass and acceleration is that we have acceleration equal to velocity over time as formula. But remember, force have the formula of mass times acceleration. But under the influence of gravitational force, the A will change to G, which is acceleration due to gravity. I think that is the relationship between mass and acceleration. Then we talk of impulse and momentum. Impulse is force times time, and momentum is mass times velocity. Then we talk of force, which is the force time graph. So these places you just have to be going through them. When you move further, we talk of conservation of linear momentum, where linear momentum can be changed to angular momentum. At the same time, impulse can be changed to linear momentum, and so on. Then we talk of motion in a cycle. Under motion in a cycle, we see W, which is angular velocity, and the formula of angular velocity is either theta over t or angular velocity equal to v over r. Then we talk of centripetal and centrifugal force. Centripetal force is the force that tends to keep an object in a circular path. Then this centrifugal force is a force that tends to bring an object out of the circular motion. Then here, applications, you just have to study them. Then simple harmonic motion. When talking about simple harmonic motion, from the word oscillatory, it is the to and fro movement of an object. And here you just have to learn certain formulas such as T equal to 2 pi into square root of L over G, which is the formula for period, and W equal to theta over T, and so many of them. The definition and explanation of simple harmonic motion, which is the one we have done. Examples of systems that execute simple harmonic motion, for example, beating of your heart, movement of a string, and when movement of a turning fork, of a vibrating turning fork, and so many of them. Here we talk of period, frequency, and amplitude. There is relationship between period and frequency. Period is the reciprocal of frequency. At the same time, frequency is the reciprocal of period. Then when talking about amplitude, is the maximum height attained by a simple oscillating motion or simple oscillating body. Then when we move further, we have velocity and acceleration of simple harmonic motion. All these one just have to treat them. Simple treatment of energy change in simple harmonic motion. You see the relationship between W, which is work, and power, and so many of them. Here we talk of force, vibration, and resonance. We talk of force vibration. For example, when a vibrating body is brought towards a large area, then that area will also be vibrating. That is what we call force vibration. At this resonance, you see the definition under simple harmonic motion with simple example. Then we talk of conservative and non-conservative fields, acceleration due to gravity. When talking about acceleration due to gravity, it is denoted by symbol G, and it indicates a constant of gravitational force, which is 10 meters per second squared. Then we talk of variation of G on the Earth's surface. G varies from place to place. You just have to study them carefully. The distinction between mass and weight. 1. Mass is a scalar quantity, but weight is a vector quantity. Then we talk of escape velocity. This escape velocity is under gravitational field that you mostly see. Escape velocity is the velocity that a moving object in a circular path will take to escape from that circular path. We call it escape velocity. And parking orbit and weightlessness, you just have to study these ones. They are very simple. Then when we move further, our fourth topic here is gravity. Then when talking about gravity, we have Newton's law of gravitational field, which states that every mass or every object attracts other objects, which is directly proportional to the product of their masses and inversely proportional to the square of their distance between them. Then when you remove the proportionality sign, you will have to introduce G, which is known as gravitational constant, and is equivalent to 9 times 10 raised to the power of minus 11, if I'm not mistaken. Then here you have to give the examples of conservative and non-conservative fields. They are very simple. Deduce the expression for gravitational field potentials. Identify the cause of variation of G on the Earth's surface. Then differentiate between mass and weight. We have done that. Determine escape velocity. The formula for escape velocity, which is VE, is equal to square root of 2 pi G. Square root of 2 pi GR, or square root of 2 pi G over R. I think it's something like that. Then when you move further, the fifth one here is equilibrium. When talking about equilibrium, it's a state whereby there's no observable change between two objects in action. Then we have equilibrium particles, we have coplanar force, principles of moment. Moments, the formula for moments is force times perpendicular distance. Then moment of force, which is the same as this one. Then we talk of simple treatment and moment of a couple, which is Toku. Then we talk of applications, conditions for equilibrium of rigid bodies under the action of parallel and non-parallel forces. We just have to study this one. Then when we move further, we have resolution and composition of forces in two perpendicular directions. We have resultant and equilibrant, center of gravity and stability, stable, unstable, and neutral equilibrium. When talking about stable equilibrium, is when an object displaced will return to its original position. Unstable, when the object is kicked, it will go and form, it will not return back to its original position. Then when talking about neutral equilibrium, it is when the displaced object go and form new position in new place. We call that one neutral equilibrium. Then when we move further, we talk of topic 6, which are work, energy, and power. You know what work is. The formula for work is force times distance. Under energy, we have mechanical energy, and mechanical energy is divided into potential and kinetic energy. Potential energy have the formula of mgh, while kinetic energy have the formula of half mv squared. Then when talking about power is work done over time taking. Then number 7, we talk of friction. Friction is the force which tends to oppose the motion of an object. Then we talk of simple machines. While other simple machines, we have things like mechanical advantage, velocity ratio, load, effort, and efficiency of a machine. Then from there you see things like first class lever, second class lever, and third class lever. So you just have to study them. They are very simple. For example, the formula for mechanical advantage is load over effort. The formula for velocity ratio is distance covered by effort all over distance covered by load, and the formula for efficiency of machine is load over effort times 1 over velocity ratio multiplied by 100%. Then we talk of definition of simple machines here. You know what simple machines is? They are machines through which you can use small effort to overcome big loads. Then we talk of types of machine. Other types of machine, we have first class lever, second class lever, and third class lever. Then we talk of mechanical advantage. Mechanical advantage is when you use small effort to overcome big load. Velocity ratio, I've defined that, and efficiency of a machine. Then in topic 9, we talk of elasticity. Elasticity is the ability of the material to return back to its original length or original size after being stressed by external forces. Then under elasticity, the person called Hooks, lay more emphasis on elasticity. He states that provided the elastic limit of an elastic material is not exceeded, the tension is directly proportional to the extension. That is, the more you force, when the increase of the load on an elastic material will lead to its increase of extension or compression. Then topic 10, we talk of pressure. Then when the formula for pressure is force over area, just have to know the definition of pressure and its formula. Topic 11, we talk of liquids at rest, which we call, under this place we have things like surface tension, viscosity, which is known as friction in liquids, and that is all. Topic 12, talk of temperature and ease measurement. Here you just have to know the unit of temperature, the apparatus we use to measure temperature, such as thermometer. And thermometer is divided into 6 thermometer, degree Fahrenheit, and so many of them. Then topic 13, talk of thermal expansion. Under thermal expansion, you see things like linear expansivity, cubic expansivity, and so many of them. For example, the formula for linear expansivity equal to L2 minus L1 all over L1 theta, where L2 is the increase in length, L1 is the original length, and theta is the temperature. And that is all in this category. When you move further, we have gas laws. Under gas laws, we have Charles law, Boyle's law, and general gas equation. Quantity of heat, which is H equal to mc theta. Change of state, body can change from one state to another through melting, icing, which is also known as freezing, or evaporation. Then talk of vapors, structure of matter, kinetic theory. You understand those ones, just read them, they are very simple. Then heat transfer. Heat can be transferred through conduction, convection, and radiation. You have to read them. Waves, we have different types of waves. We have mechanical wave and electromagnetic waves. Under mechanical waves is the wave that requires two material medium, and in electromagnetic waves, there's no require for material medium. For example, we have electromagnetic induction such as X-ray, gamma ray, ultraviolet, visible light, infrared, and radio waves. Those ones, they are under electromagnetic waves. Then we talk of propagation of sound. So when talking about propagation of sound, you just have to read them. They are very, very simple. Then from here, you have characteristic of sound waves. Things like echo, those kind of things, you see them under characteristic of sound waves. Then here we talk of light energy, which is also known as optic energy. Reflection of light and plane curve surface, optical instrument. Refraction of light, dispersion of light and colors. Under the dispersion of light and colors, we have primary color and we have secondary color. I think primary colors are blue, red, and green, and the combination of primary colors form secondary colors. When talking about dispersion of light, we have about seven colors in light, which are known as red, orange, indigo, then green, blue, and violet. So those are the things you just need to know here. Then refraction, you know what refraction is. When you put something in water, for example stick in water, it will appear as if the stick have burned. That is refraction. Optical instrument, there are instruments, we have concave, convex, and so many of them. Then when we move further, we talk of electrostatic. For example, electrostatic is a constant electricity, or electricity in a constant position. So under this, we have electrostatic by induction, by friction, and that is all. We talk of capacitors. Capacitor is a device for storing charges. Then we have capacitor in parallel, capacitor in series. Then here we talk of electric cells, which is the connection. We have electric cell, just read them, you understand. Current, electricity, electrical energy, and power. You just need to understand this. For example, P equal to IV, and electrical energy have its own formula. For example, P is equal to IV, and remember P also is equal to W over T. You have that your W equal to IVT. Just read and understand them. Then 20, Magnets and magnetism, it's not take time. Force on a current carry conductor in a magnetic field. Electromagnetic induction, as I stated earlier, we have X-ray, gamma ray, ultraviolet, visible light, infrared, radio waves. There are about 7. Then here topic 36 is a simple AC circuit where you will see something of RMS, all those things. They are very, very simple. Then here is conduction of electricity through conduction materials. So you just have to study them. Or you can see conduction of electricity through gases is very simple. Then here we have elementary model where the person known as Albert Einstein, he brought one formula here which is E equal to mc square, and so many of them. You just have to study them. Then introductory electronics, they are very, very simple. So this is your 2023 physics Jamb syllabus and things you need to know. If you find this video interesting, please consider subscribing to our channel for upcoming useful videos. Thanks for watching.